Hi, I'm Dustin Carlino, and this is the final presentation from the AB Street team for the Taiwan Presidential Hackathon. So thankfully I was joined by some other people in this project, Michael Kirk, Ewan Lee, Mara Cruz, Robin Lovelace, and some others, and I want to thank them for their help. So the United Nations Sustainable Development Goal number 11 calls for making cities more resilient, safe, and sustainable. And a big part of the problem is the transportation sector. So in the United States, this produces 30% of the greenhouse gas emissions. And when everybody in a city chooses to drive a car, this causes a lot of externalities, such as people dying from car crashes, contributing to suburban sprawl, a lot of noise pollution, and just like parking space taking up all of the valuable real estate in a city. So electric and autonomous vehicles can maybe help with some of these problems, but they're expensive. Some of the technology is far off, and it really won't help with the fact that cars take up a lot of space in dense cities. So there are plenty of cities that have figured out good alternatives, such as land use that allows people to live and work closer together, having a reliable public transit system, and encouraging remote work. But getting these changes to happen in many cities across the world is expensive and slow, and so the focus today will be on biking. So why is biking such a great solution for this? Amazingly, 60% of trips in the United States are under 5 miles, which is a very easy distance to bike. So one report estimates that if you could convince just 16% of people to switch from driving to biking, you'll save 7% emissions annually, which is quite a bit. Riding a bike is very low cost compared to owning a car. And in fact, even if you don't have a driver's license because you're a child, if it's safe to bike around, even children can access this. And it also helps encourage people to exercise and be healthy. And as I've said, building out the infrastructure to make it safe to bike could be a very fast process in comparison to the other things. So the question is, why don't people bike? I'm going to argue that the main issue is safety, but this video won't load, sorry. Maybe a more very terrible example of this is what it's like to bike in cities when the infrastructure isn't built for it. You'll notice in all of these cases, maybe there's like a little bit of paint on the road or a dedicated shoulder space for biking, but like there's no protection from people driving, and so this is just really dangerous. And so this is the reason why people don't bike. It's because roads aren't designed for it. So what are the ways to make this better? We don't need any magic new technology here. Plenty of places have figured out what to do. If you have protected bike lanes that are physically separated from cars, this goes a long way. And in the Netherlands, they have a lot of these Dutch-style protected intersections. And so there are plenty of examples around the world of how to design proper cycling infrastructure that works well and keeps people safe. So what's the resistance? What happens when different cities will propose adding new bike lanes somewhere? You see a lot of really common arguments from the public. Things like, oh, we're going to lose parking space, or if there's less space to drive, actually cars will back up more and that'll cause more pollution, or only certain people will use it. And a lot of this just kind of stems from miseducation about the subject. And so I think that the real problem here is actually kind of about communication. So what do I mean? Let's look at examples of how the city government will choose to communicate to people about plan projects. So this is Seattle's Bike Master Plan that's supposed to be built out in a couple of years. And this is a graphic from a 100-page PDF report. You can't really interact with the map. You can't even really see the names of the streets where the bike lanes are. They do have a web map through ArcGIS, but it's not terribly easy to understand what the changes are here. You have to kind of click on each individual segment and then read through these attributes to figure out what exactly is changing. Sometimes there are these like nicer infographics that kind of like summarize the high-level idea behind a change, and then you can also dig through the project documents and find like a lot more detail than you might care about. And sometimes they'll have kind of these architectural renderings, but the problem with all of these tools is that they're not really interactive. You can't just ask questions that you would want to know as somebody commuting and considering using the infrastructure. Like, how much time will it save me? Will it be safe? Will it connect to everything else in a nice way? And so going the other direction, you have advocacy groups that fight for that petition cities to build safer infrastructure. And so this is an example of a group in Seattle proposing a network of healthy streets, and sort of the state of the art is them drawing colored lines on top of Google Maps, and you can't plug in routing and see how will this affect trips if this was built out. This is a very like primitive way of communicating. A very good example of a way of communicating is this tool called StreetMix that lets you design the way space is used along a single street segment. And so this is the kind of thing that I think the world needs more of. And so now let's talk about what we can do better. So we've created the AB Street Ungap the map tool for planning bike networks. So this is a map of central Seattle, and you can see different types of bike infrastructure highlighted in green. And if you want to get a better sense of what this infrastructure looks like, we can zoom into an area near the university, for example, and see, for example, one of these bike lanes that's directly adjacent to street parking. And so those videos of people having collisions earlier could be a potential risk here. And nearby, you see something a little bit better, which is a bike lane that kind of is protected from traffic by paint, but also some bollards kind of placed in the middle there. So that's a little bit of a better design. So with this initial view, you can also explore related data. So a big part of biking in Seattle is avoiding the hills. And so if we turn on the elevation layer, you can kind of get a sense of places that are a lot more steep, and maybe plan your or understand where it's easier to ride and not ride. If you wanted to get the view at an individual street level, we also kind of show incline and things like that. But what's interesting is you can plan a trip and see what it looks like today. So let's say that I want to come from in like the residential area north of the university and go down to say like Capitol Hill. So this is sort of the route that it recommends, and just want to show that we have a lot of detail like elevation, and if you drag the marker around, you can even use this as another way of kind of exploring the elevation patterns in the city. But anyway, the route that it's sort of chosen is the most fast direct route. But you'll notice 30% of it is along this high stress road. So what does high stress mean? If we zoom in, you see that it's it's 4 lanes, sometimes with parking both directions. And so cars go fast here. This is likely to be a place that's kind of dangerous. So the tool has recommended an alternative. And if we look at it, it looks like it's a lot safer, but it's about a half mile longer, and so it'll take us 3 minutes longer to do that. And this is kind of a common story with biking in Seattle. You can find a quiet route if you're willing to go longer. But let's say that we wanted to fix this problem and just add lanes to this road. We can use this tool to add bike lanes. And so if we kind of select the area that we want, let's go ahead and change 23rd all the way down. And if the route that the route that it found isn't quite right, you can sort of drag it around and adjust the path. And then we can decide what we want to put here. We could just have paint, but actually want to put some kind of like concrete barriers and planters to protect from traffic. So if we make these changes, it looks like it worked in most places. And so if we zoom in, you can see the new configuration. Now it's just 1 lane of traffic each direction, and we have this nice protection from people driving. And if for some reason you didn't like this, you can click on an individual road segment and kind of adjust further. For example, if for some reason we wanted to put the bike lane on the other side of the barrier, we could do that, although that makes no sense. So let's cancel that. Right, so we've made these changes. Now let's evaluate how they affect our trip. If we load the trip again, you'll see that the direct route is still the same, but now a very small portion is along, actually it looks like we're selecting the other one. Let's do the alternative. Yeah, so now the most direct route is luckily along the road that we changed, but the difference is now it's not stressful. So more or less we fixed the problem. So we fixed this one problem, but we really want to know how it affects different people that are taking trips in the area, not just this one route. So if we go to this last panel, we can predict the impact. And so let's start that calculation. It's going to take a minute because it's calculating the paths that 300,000 people in the area will use. But just to mention a little bit about what this does, it takes existing travel demand data for people taking commute trips in the area, and it tries to predict which ones will possibly make use of the infrastructure that we've built. Based on some different assumptions. And so you can see in the area that there are about 300,000 total daily driving trips that kind of stay within this part of the map. And there are some assumptions for who would possibly consider switching. So here the defaults are nobody wants to spend more than 30 minutes biking or climb more than 100 feet of elevation. So based on that, about a third of the trips would possibly consider changing the route. And so then the final panel tells us how many will actually change because of or how many would consider switching from driving to biking based on this road that we've edited. And it looks like not that many, only about 900. This view also tells us the places that are most likely to get us the big benefit. So if we look for the roads that are highlighted in red and hover over one of them, about 1,000 of the trips try to take Eastlake, but don't because it's not a safe route. And there's some other notable corridors in the city like 45th and Market Street over here in Ballard. And so this view is sort of a data-driven estimate of if we change some roads to make them better, how many people might switch over. So based on the final calculation, we can kind of get a total vehicle miles traveled daily, and then multiply that by assuming everybody drives the same trip per year, and kind of estimate the CO2 emissions saved. So this one little change doesn't really help that much, but luckily I've come up with a proposal that covers a little bit more of the region, and so the areas in blue are some of the other places that I think are important to fill in with bike lanes. And so if we repeat the mode shift prediction there, we can kind of get a better estimate of how things work. While this is loading, I'll just mention a little bit about how the software works. It's written in the Rust programming language, which has some advantages. You'll notice that I'm running the software locally right now, and it's a lot faster to do so. But I can also share things on the web, and I'll show that to you in a minute. So based on these like further changes, we get about 20,000 people deciding to bike, and almost 30,000 tons of CO2 saved initially. And again, the map shows you the remaining gaps. Things like Market Street and 15th look important to consider infrastructure there as well. But I mentioned the web, so since I made this proposal, I want to share it with other people. I can just click this button, and then this will upload the proposal, which is expressed as a JSON blob. And then now I can share this URL, and somebody will be able to load this in a web browser and get exactly the same view here. Right, so the web browser version of AB Street you can see running here. It takes a little bit longer to load, and it's slower than the native version. But the advantage is I can take this URL and then share it with whoever I want, and kind of talk about this proposal if I wanted. And so that's one advantage. But going back to the faster version, we're just in Seattle here, but the software works anywhere in the world, and so we've imported probably about 100 places through. Or 100 different cities throughout the world. So I just want to show you an example over in Leeds in the United Kingdom, just to show you that the software can work anywhere thanks to OpenStreetMap data. So you'll notice here that the city center seems to have a lot of good bike infrastructure, but it gets fairly suburban quickly, and we have all these like large roads without any infrastructure at all. So maybe if we just like select some of the larger roads and try to add something, you'll notice that it wasn't really able to make changes in a lot of places. Here at this one intersection, it looks like it added a lane, but actually on opposite sides of the street. And the problem is if we look at, for example, street lane, quite a name. If we look according to OpenStreetMap data, this road is just a single driving lane each direction, and so we don't really have accurate width information here. Based on the distances of the buildings from this road, the road's probably actually wide enough to support cycle lanes without taking too much space away from driving, but this is kind of a limitation of the data set. Or maybe the road really is that narrow in real life. It's unclear. But anyway, if the list of available cities here isn't one that you want, on the desktop version, you can also import a new place using this panel here. So my hope with this Ungap, the map software, is that I can help achieve the sustainable development goals in a couple different ways. So first, when the city government comes up with a plan to roll out a bike network, they can communicate the plan much more visually and sort of gain support faster by being able to explain what the impacts on individual commutes are a lot better. And then second, I want to help educate the public about long-term consequences of transportation changes. In particular, the concept that this infrastructure doesn't serve me personally, but it serves a lot of other people. And so if they choose to shift away from driving, then in fact there's less cars on the road, and that's kind of the end goal here. And then the third use is I want to increase the engagement of individual citizens and advocacy groups, and make it really easy for them to come up with their own vision of what biking in a particular city looks like, and share that vision out and get support from government for it. And so what are our next steps? This week we're going to start launching to a bunch of different partners we have in the Seattle area, spanning advocacy groups like Neighborhood Greenways, entities that are more connected with the city government like the Bike Advisory Board, and then the general public through the Seattle Bike Blog. Then next week there's some sort of critical bugs and features we want to fill in that we didn't have time to get to. And then we also want to get better elevation data set up so we can roll out to more places like San Francisco and New York. And then there's also sort of a new direction that we want to take things for low traffic neighborhoods, and we're going to start prototyping that. And then the week after that, we're going to kind of take that, we're going to take all the feedback we receive from these groups and these stakeholders so far and kind of figure out the best next steps from there. And so the AB Street project has been running for a while, and there's a lot of other areas that we're interested in besides just bike network planning. The one that we're going to look at next is probably low traffic neighborhoods, which have a lot of traction in the United Kingdom right now. But there are some other areas that we're interested in expanding. And so this is a little bit challenging. So our goals, or our top priority is always to remain totally open source and build software that's accessible to everyone, not just experts in government or people who are able to pay an expensive license. But the challenge is we're a very small team and pretty limited resources. And so we need to figure out how we can find people to help out, and then also develop government buy-in to support these projects and give them some legitimacy. So thanks for watching this presentation. You can find everything about the tool at bike.abstreet.org. If you hit any problem, if you want to import this into any place, you can file an issue on GitHub or contact me. And if you want any more information about the sort of detailed theory of change or the different stakeholders, there's a bunch of links to the documentation along here. Thanks so much.